Welcome to CW 4.3. Today we're starting our graphing unit. So the first problem is find the domain of each rational function. So to do this, quickly recall domain. We've been doing that for a while now. And to find domain, it's going to be helpful to think about what x can't be. That's always going to help you frame your mind as far as approaching these problems. So if you look at this, you focus on the denominator, because the numerator doesn't really matter for domain. You look at there and think, okay, I can see x can't be 3, so we're going to write x such that x can't be 3. And this is called set notation. So this should be familiar from trigonometry or algebra 2. This first x means all x. That vertical bar means such that. And this next part means x can't be 3. So it's basically saying x can be everything except for 3. So now we go to B. We'll put a line right here. So for this one, you could factor it or just think about it. I can see that x can be everything except for plus or minus 3. And this last one's pretty cool because this bottom one, x squared plus 9, if you try to make it equal to 0, you'll notice that this is impossible. You get x squared equals negative 9, which can't be solved. You can try to root it, but again, you know it's a negative in there, which means there are no real solutions here. So if there is no restriction on the bottom, then the domain is going to be all real numbers. So you could write that R. Some people like writing this. This is like the fancy way. Or you could write negative infinity to infinity. Those are all acceptable. Part 2, finding a vertical asymptote. So a couple things to remember here. You have to find the VA after simplifying. I can't emphasize how important that would be. I can't emphasize enough. You really have to write that down. You got to find the VA after simplifying. For the domain, what's interesting is you'll notice we didn't really do any algebra. That's because for a domain, you find domain before simplifying. So it's a very, very important thing to note for yourself. You're always going to find the domain before you do anything, and you always find the vertical asymptote after you simplify. So for A, notice how it's saying find the VA. It's not saying find the domain, which means you want to do this thing, can I simplify it? And for this one, you can't simplify it. So now you just focus on what makes the bottom 0. So think x squared minus 9 equals 0. You can see it's 3 and negative 3. So your VA is going to be x equals 3, negative 3. Notice how I'm writing x. If you just write negative 3 and 3 without the x, you will get marked wrong. So don't forget to write x. You absolutely need the equation. So A is pretty straightforward. You notice it's pretty similar to what I did up here. Now B is where it gets interesting, because for B you'll notice the bottom can be factored and it actually does something. Let's see what happens. You factor the bottom, and you notice this actually can be simplified. These cancel out, and you're left with 1 over x minus 3. So now you look at the simplified version for your vertical asymptote. You're going to write the VA is x equals 3. Now, you might be wondering, well, what happened to this thing? So this is still a domain restriction. If I asked for the domain, you would still say x cannot be 3 or negative 3. What's happening in the graph right here is a hole. So whenever you cancel right here, you're going to write this creates a hole. And where the hole is located is going to be the value you cross out whenever it makes it 0. So that's x equals negative 3. And the exact coordinate, negative 3, comma, you simply plug in negative 3 to this expression right here, and you can see that would be negative 1 over 6. So that'd be the whole location. Now for C, this should be straightforward. You'll notice it's quite similar to the one up here. If the domain is all real numbers, that means there is no restriction. So for this one, for vertical asymptote, there are none. Not too bad. Now the last part, horizontal asymptotes. So in Algebra 2b, you learned a whole bunch of rules, and I'm going to quickly go over those rules here. So Algebra 2b, whoever your teacher was, they probably made you memorize these rules, and that's what pretty much every Algebra 2 teacher makes you do. So our generic form is y equals a x to the m plus dot 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 over b x to the n plus dot dot dot. They tell you there are three cases. Case 1, that would be m equals n, meaning the exponents are equal. If that happens, you simply write HA is y equals a over b. You just take the coefficients right there. Now case 2, that's going to be the bottom is bigger, so n is greater than m. So let me write that nicer. N is greater than m. If that happens, the horizontal asymptote is y equals 0. And case 3 is going to be the top is bigger, m is greater than n. And if that happens, there is no HA. So again, if the exponents are equal, we're really focusing on these right here. Then you just write it's a over b, the coefficients. If the bottom is greater than the top, then that would mean 0. And if the top is greater than the bottom, then there is no HA. And your Algebra 2 teacher just wrote this on the board. They might have explained it a little bit, but most teachers don't really explain it in detail because you don't have the tools yet to really think about it. Now that we have done limits, this should all look familiar. This should look like what we just did. What this is actually limits to infinity. It's the exact same thing. So if you remember, limits to infinity, if I'm going to infinity, the things after the leading coefficients or leading terms, they don't matter. You just cross it out. So what we're really doing is we're saying take the limit as x goes to infinity of 4x over 2x squared. Now we simplify this. Well, we can see the 4 and the 2 will simplify, the x will simplify. So I'm going to get 2 over x. Now plug in infinity, and this is going to go to 0. So your HA is y equals 0. So you did that for your homework, and notice how that fits this rule, this case 2, exactly. The bottom exponent is bigger, therefore it's y equals 0. And this is why. So for B, I can see the powers are equal. So in case 1, so in algebra 2, you just write it's 4 over 2. Now in pre-calc, we can do the limits. We can say, well, the 1 doesn't matter. So now I'm just taking the limit as x goes to infinity of 4x squared over 2x squared. But that simplifies to 2, which means your HA is y equals 2. And for the last one, we know it's none because we're in case 3. And again, in pre-calc, if I were to tell you, take the limit as x goes to infinity, this one doesn't matter. Let's simplify that. That'd be x. So this would go to infinity. And if you're going to infinity, that would mean there is no HA. That's it.